Okay, we're going to take a look at these two problems, but I'm going to do it a little bit. It's going to get messy if I do it on this graph and right now. So I'm going to show you how to graph it using Desmos, the way I suggest graphing it. Okay, so the first thing we got to look at is making this kind of back to its parent function, right? Which would be y is equal to log base 4 to x. So that will be the parent if we graph this, right? So let me get that over here. We're going to call that log base 4 x is equal to y. So if I have that, right, and I know my x and my y, I can just change this into exponential form. So what I'm going to get is I'm going to get, change that to exponential form. I'm going to have x, or 4 to the y power. So 4 to the y power is equal to x. Okay, so I just want to put in things that I can graph very easily from this. And then I'll do my stretch and my transformations. Okay, so I can get my x, y points. Remember, just to get the log, right, we can swap the x and the y points. So one of the things I know about this, well, or we can look at this, y is going to be, if y is equal to 0, x is equal to 1. So for this graph, right, we got 1 for x and 0 for y. Well, we know that's true. Now, if we know y is equal to 1, we know that x is equal to 4. And then we could do another point. Let's go ahead and make this into a fractional answer. So if we say that y is negative 1 instead of 1, negative 1, we get 1/4. Okay. So I'm just going to plot those real quick. So we go 1, 0. Right, so 1, 0, and then we had 4, 2, 3, 4, 4, 1. So right here, and then we had like negative. We had 1/4, and we had a negative 1. So that's down here. So you can see that parent function curve. Right, our asymptote is going to be for the parent function. Asymptote is equal to 0. Right, so this is actually my log. My parent log function. You can kind of see how I graphed that, right? So I kind of switched it to exponential, and I put in values for y and then found x. Value for y found x, value for y found x. Okay, now we need to apply these transformations on that multiplier and these shifts. So the way I'm going to do that so this doesn't get messy, because you can kind of go through this same process, right? You can plot your parent function. You're doing it in pencil, then you can apply your transformation, get new points, kind of erase this. So you just don't want to put the curve in, you can just put points in. And then change your points to match each transformation. That's kind of what I'm going to do on Desmos, so we can see it. So it's nice and neat. Okay. Okay, so on Desmos, you can see I got the parent function graphed in. So these are the points that I just plotted. You can kind of see the way that curve goes. Now we want to put that transformation. We want to multiply all these points by 2. So if I multiply, let's multiply this one. This has a multiplier of 2. That means that my increase on this, right, my output is still going to be at 0, because that multiplier is for the y. Right, it multiplies the x, but increases, so the x stays the same, but the output would increase by 2. So if I multiply this point by 2, it should be up here, and this one, 1/4, should actually get smaller, right? So here's my multiplier of 2. Let's see what that looks like. Boom. So there it is. It moved up. This actually shifts down smaller. I don't even want to mess with these that much. Okay, but you can see that my multiplier of 2, all right, this output is 1 for the y, multiply it became 2. So there's my new point up there. Still at this point, this doesn't change, right, because it's 0. So that multiplier on the y doesn't change. Okay. And that was this graph when we added 2. Now, Now let's look at it if we do our transformations on it, right? So our h is equal to 1 because it's -1 here. So that means we're going to go 1 to the right. So we go here, and then k is going to bring it down 1. So we should have a point that goes through, what is this going to be? 2, -1. And then this point should come down 1 and go to the right 1. So I should go through 5, 1. So let's see, take a look at that. So 5, 1. Let's make this one live. There, no, come on. There it is. Okay, so there it is, going through 5, 1. Okay, boop, boop, 5, 1. And you see it shifted over to here too. So I did my shift on this, where it went down 1 into the right 1. Down 1 to the right 1. It's this point right here. To -1. Yep. So there it is. Down 1 to the right 1 puts me at that point there. So I kind of get those 2 points. You can kind of see the curve off of that. So that's kind of the way I would graph it. I would graph, first of all, I would graph the parent function. Just like this, I can get my values on the parent function. Remember, I changed that into exponential, and I plugged in values for y to get the x. I'm working backwards because that's kind of what we do with the inverse. And then I took each point and I multiplied them by a factor of 2, right? So the y value gets a factor of 2 multiplied. So this becomes 1, this stays at 0, and this becomes like larger down here somewhere. Okay. And then once I had that on, now I'm going to take this point and I'm going to shift down 1 into the right 1. So it puts me through there. Take this one down and over 1, and it should put me through there. So there we go. Boom. So that's how I would graph that one. You're going to have like one of those on the test.